So let's start off our discussion of differential equations, solving them with a first order homogeneous problem. Now the reason why we call it first order is that the highest derivative is only a first order or derivative to the first power in the equation. That's the highest. So let's take an equation, differential equation, first order. And let's think about how we're going to solve this. Well, if I want to do a derivative, the easiest derivative that I can do is the exponential function. And I want to make this solution as general as possible. So I really don't know what form I'm going to really come up with, what the solution is going to look like. But I'm just going to come up with an experiment. And I'm going to say, let's try some homogeneous solution that is equal to C e to the RT. And now let's throw this into our differential equation. And let's substitute in. And now I can take the derivative. Well, my constant's just going to come out of the derivative. And then I'm going to take the derivative of e to the RT. Well, remember to use the chain rule. So I'm going to have e to the RT times the derivative of my exponent, chain rule, minus 3 C e to the RT equals 0. And now if I take the derivative of RT, that's just going to be R. So I have C R e to the RT minus 3 C e RT equals 0. And now I can cancel out. The C's are going to cancel out. The e to the RT is going to cancel out. And what I'm left with is R minus 3 equals 0, or R is equal to 3. So my homogeneous solution, which is just going to be my solution that I'm looking for, is going to be C e to the 3t. Now you can put that formula back into our original differential equation and you should come up with 0. The other interesting thing is you have this C in the formula, some constant. That C can be equal to anything, which means that the homogeneous solutions are infinite. The only way that we know what exact value of C we will use for a particular problem, we need to have some initial conditions. And we're going to do a problem showing how to come up with initial conditions, or what to do with initial conditions to come up with these constants. But for this point, at this point here, we're just going to leave our solution general, and in this problem our homogeneous solution is C e to the 3t.